Hi, I'm Eric Normand, and I reviewed a Clojure-based text editor called Salza Liquid, and it's really awesome. And after doing the code review, I felt like I gave some good points. It was kind of a high-level overview. The code is so good, it wasn't like nitpicking little details about how things were implemented. It was more, is your core data structure really the thing you want? And I gave some recommendations and then sent it off to the person, Moens. He seems very grateful for it. But then you know how it happens, you read some code and you think about it and you talk about it, and just over the course of the day, this all happened yesterday, over the course of the day, I started thinking about what I said, and I prompted him to do it, but the programmer prompted him to think about this, but it happened to me too. So I am now going to give my more concrete recommendations. Maybe you can watch the process of how I break down this existing abstraction, the slider. I got the code here. It's a slider, which is a way of representing a text buffer with a cursor and some selections and stuff like that. And of course, all the text in it. And so you can follow along. If you go to this repo, you'll see it's right there. Okay, so the main thing I want to look at is the constructor called create. Creates a new slider. It's got a bunch of things in it, a bunch of keys and values. It's a map. And one of the things that I try to do when I'm looking at something like this, and I'm trying to find a more solid foundation for my abstraction, is I kind of like zen out. And I think, what does it even mean? Right? I go through this in one of my talks where really you want to find some kind of metaphor that governs the whole thing. And when I look at this, I see the metaphor. It's that you've got the text before and the text after, and your cursor is kind of sliding back and forth. And as you do that, you're like popping it off of one list and pushing it onto another list. So everything's always, the cursor is always ready to insert. And that's fine, and I'm sure a lot of text editors do something like that. But when I really sat down to think about it, like if we're just really honest, that's an optimization, right? The data structure of having two lists, it's really just a way of ensuring that when you type, it can be inserted really quickly, and that operations around the cursor are fast. For instance, operations somewhere else are not fast. And so it's just an optimization. So maybe it's not something that we should really base our whole thing on. It's premature optimization is what I'm saying. I don't know how Emacs is implemented, but I imagine it's something like this. And when Emacs was written, memory was really expensive and kind of slow, and anything you could do to like optimize for insertion, so that people could type faster, was probably necessary. But we live in a different time. We have much more memory. We have a lot of a better garbage collection, all that stuff. Why would we start our journey with that optimization nowadays? Maybe we need to optimize for something else, and we've prematurely cut off that avenue. So my first recommendation would be like, just liberate your mind from that optimization. And like, let's just go back and peel back those layers of the onion. Okay, another recommendation I gave was to think about trying to figure out the minimum number of operations you would need that everything else could be implemented on top of. And part of that is also not just the operations, but the concepts. I mean, how many concepts does your abstraction need to be based on? And of course, the more I thought about it, the more I was thinking about the marks and how what they represent is regions of code, named regions of code. And I thought about the point, which is in one name, and the point is the name of the thing. So it's a named place in the code. It's not a region, but if you squint, you could see that maybe it's a region of length 0. And so then having a special place called point that you have to keep track of differently from the marks is now unnecessary. You could make the point just a regular mark with the width of the region to be 0. And the same math will apply, if you insert text at the beginning of the buffer, all the marks have to be moved over to the right, and the point will have to be moved over to the right too. So maybe that's an interesting thing, is that the point is just a special mark that the text editor uses for where to put the cursor. And then that got me thinking, well, like now a lot of modern editors have multiple cursors, so that might be an interesting way, because the marks already anticipates having multiple regions, a highlighted region and other places that you could mark in your document. So that already, you can have the multiple cursor thing just be, just fall right out of that simplification, getting rid of that special point as just a special concept. Of course, then you'd have to get rid of that before and after thing, because it really is centered on the point. The other thing, total lines, it even says that it's an optimization in the comment. So I'm just gonna say, like, maybe we don't need that. We can add it in later as an optimization, but like, let's not think of it as part of the core of the abstraction. And then the line number also, it says meta information for fast retrieval of the current line number. Fast retrieval, so it's not actually necessary to store it. It's only necessary if you want it to be fast. And I would question whether that's true, right? How often are you retrieving the current line number, and is it really slow when you do that? Okay, so I'm gonna get a marker. That's why I'm here in front of the whiteboard. And I wanna list out the concepts that we have so far. So we have the text. Obviously, you need to store the text. And we have the marks. And currently the marks are, I'm gonna say they're 2 points. They're 3 things. They're a name, so let's do a name, and 2 points, the start and end point. Start and end points. Okay, so those are the 2 things we have so far. And then we say that we have a special point that is where the cursor goes. Special mark where cursor goes. And we'll give it a name that, like, we'll say don't use that name if you're using a mark and you're writing code. All right, so there's one other thing that I think is very important in here that is not captured in this. And I think it's kind of a signal. It's like a smell, you know. It's all of the operations that you have written in here. Well, not all of them, but a lot of them. They look for new lines. So new lines are obviously important and different. They're like a special case of character. And so I wonder if that shouldn't be part of the main abstraction. That instead of just having text, which is in essence a list of characters, maybe it should be a list of lines. That's where my mind goes. That you're always checking for the new lines, you're filtering, like it's weird to count them, and moving around. You have to check, is this a new line? Am I going to the end of line, beginning of line? Those kinds of operations. If you made the main, abstraction a list of lines, and each line is just characters with no new line at the end, right? You split on new lines, let's say, and you made it a list of lines. I would. So to me, that is a much more natural metaphor for what's going on, because when I'm coding, when I'm editing text, that's how I think. I think I can move left, right, and I can move up and down my lines. And I think that, when you remove all these premature optimizations, you start to see that, wow, I can just implement exactly what the mental model of the user is, right? The mental model of a text editor, person using a text editor, is lines of text. So I'm gonna go down that road. I don't know, I've never written a text editor, okay? But this is the exploration that I'm doing. So this text is a list, and I say list, I'm not talking about the data structure list. I'm talking about like, if I wrote a list on a board, it's a list. List of lines. We will have to eventually, define it in terms of data structures. But for right now, we're not thinking about, is it a vector, is it a list, what is it? Let's not worry about that right now. We can always optimize later. What we want to do is define the core abstraction and the operations that happen on that. Okay, and you also know that I like monoids, so I might be going in that direction in a second. So then, all right, here's the thing. One of the reasons I like reading history, like the history of programming and how we got where we are. There is a really nice paper called The Early History of Small Talk by Alan Kay. And he talks about how small talk let them do some really elegant things. But then when they actually tried to get new programmers, beginners, with no experience to program them, it wasn't so obvious how to do it. And they thought, well, it's like a 7-line program in Smalltalk. Why can they not even get it? And it's early days of trying to teach true beginners programming. One of the examples he gives is how he went to his hotel room and he totally refactored the whole text editor. Because, they had the first WYSIWYG text editor, and he refactored the whole thing because he realized they had all these operations. They had insert text, they had replace text, they had delete text. And so what he realized was All of these things could be implemented with one operation, insert. But what insert did, it was really like replace. Let's call it replace. That's a better name. So there's two arguments to replace. There's the region, right? So that's like a start end. This is not real code. And the text to replace it with. So if your region has a 0 width, so the start is equal to the end, and you put in some text, that's the insert, right? You just replace nothing with more text, and so it gets inserted. If you selected something with the mouse, and so you had the start and end, are far apart, and you inserted text, that would replace the text. But then you could replace a single character with nothing, with the empty string, and that would be like delete, right? So all of those things collapsed into a single operation. And so I actually think that this might be a good candidate for, it is a good candidate for that single operation that you have on text, right? Now, that's on the text part. Moving the marks around and stuff is different. Okay, also, there's a lot to say. It's multidimensional, so I can't just like linearly put it out there. If you have a mark, which we said is start and end points. So what is a point? Well, a point has to be a coordinate into the list of lines. So it's not just one number, like an index into a list. It would have to be an index into the line and then the position in the line, right? Which is actually, one of the things that Emacs shows at the bottom, right? Is like, what line are you on and how far to the right are you, right? So it's already there. It has to be calculated at some point. So could make it part of the basic abstraction. So we're going to say a point is line, number, and position in line. Okay, so that means that when we construct the slider, we're going to have to split on lines and store them probably in a vector because we want to be able to like jump to a line number. And I'm imagining that this will make left, right, up, down, the arrow keys, very easy to write. Also, jump to the beginning is easy. It's just, set the start and end point of the point mark to 0, 0, right? And the only difficult things are going to be, you're going to have to check, am I at the end of the line? Because if you're at the end of the line, hitting right should go to the beginning of the next line. I imagine that's how it works. And then replace is going to also have to deal with that list of lines, right? But the interesting thing is, like, don't think about how, you don't have to think about how, what am I trying to say? How best to write it. Like, I bet if you were really struggling with it, you could just make it super, super easy. Like, if you wanted to do a replace, well, just turn it back, the whole thing back into a string, join with new lines. When you do an insert, you join with new lines, you split it at the point, and then, or maybe split at the point first. Split at the point, join the two halves with new lines, put the text in the middle, boom, put it in there, and then re-split on new lines. I mean, you could do that. It would be slow, because like if you had to do that for each character, but it might not be that slow, and you could always optimize it later. But the important thing is that this replace will be conceptually simple, and optimizations are possible if you need them. Right, and so then this also gives you like a bunch of tests that you could write. You know, I could imagine how to implement this, but more important is like, what are the properties of this thing? So one property that you could say is, if I have a buffer or a slider and I insert another slider, or I insert more text, the buffer grows. And if there are lines in, if there are new lines in the text that I'm inserting, the number of lines increases by that amount. So like there are tests that you could easily write that would kind of give you the constraints to explore different optimizations. And they're very high level tests. You could write them with property-based testing and really have a very clear zone to work with. And because you've only got this one operation, like you can test the hell out of it, right? Like that's one of the really great things, is this operation is so abstracted, but clearly like you know what it's supposed to do, that you can just test it with so many different properties that, and then everything is going to be built on it. So it's great, it's fine. And it's like just going to be super robust, especially as you realize you need to optimize it, right? Okay. So I think I've gone over everything that I thought of, but I'm gonna just review everything now. So the text, the mental model for the text, the metaphor, the cohesive physical metaphor, is a list of lines. Then each line is a string with no new lines in it, right? So, I mean, that's how I would do a string. It's immutable. Why not use it? It's got, I mean, especially, I mean, this might be too much implementation detail, but, you know, there's a lot of potential for optimizing strings. Getting substrings is fast in Java. It's constant time. There's like, what are they called? String builders that are fast for putting multiple strings together. So there's a lot of room there for optimization. It's not necessary to do that. You know, you might find that a Clojure vector of characters is better, but I would think about strings as the implementation for each line. And then I would start with a vector, a Clojure vector for the list of lines. Okay, so that's where, you know, that's where I'd start. Points is another concept. And so the reason I'm pulling these concepts out and picking them apart is, here, let me put this down. I don't need this anymore. All right, the reason I'm picking these things apart is I think that instead of packaging them all together, you could think of them as separate ideas. Just like how you have in the implementation now, you have the marks where you slide them over to the right or to the left as a separate thing. Like it just takes that map of marks and moves it. You know, think of it like that. Like a point is something that you could pass as an argument to a thing, right? And then, of course, replace would take a, I guess we're calling this a mark. That mark doesn't actually have to be in the data structure. It's just the start and end point. And, you know, the text, and of course this text has to go in there too. Okay, so that's why I'm pulling them apart, because you can start to look at them as separate things that have their own algebras, right? So like you can merge two sets of marks together. You can add a mark, so given a name and a point, and and 2 points, you can add it. You can construct points separately. You can get the, given a text and a point, you could find the character immediately after. There's all sorts of little combinations and operations that you would want to be able to do without having to like have them all in this data structure, right? All packaged together. They can be separate. It still makes sense. All right. Then, of course, you'll want something where they're all together. But that's kind of like the keeping them together and making sense is kind of, could be seen as a separate task, like a separate responsibility. Like it's the editor's job, the text editor's job, to make sure the marks stay, that they stay current, right? With the text as things are inserted. To just slide them down a line or up a line or whatever it is. Okay, and then, yeah, the other thing I would do is this text idea. Just make this argument, instead of being a string, like you replace a region of the text with a string, make it replace a text with a text, right? Because that text, it's already going to be split into lines, and it's not going to, it's not going to have, it's going to be easier. I'm just thinking. That's about it. That's about all I have to say. So I hope that this exercise was useful, because I feel like I gave a bunch of high-level ideas before, and I didn't really give a process for how to do that, for how to, how to continue with the high-level ideas I gave. And so I hope this makes it more concrete. Peel back those optimizations and start from scratch, because you can actually add, you can find optimizations. It's not like Emacs found the best one optimization for all time. What it's done is found a path that now it can't get out of, right? Because it didn't define stuff abstractly enough. It defined stuff very concretely in terms of moving a point back and forth. Yeah, okay. Thanks, Moens. I'm looking forward to meeting you and talking more about this. So get in touch. All right, bye.